Hi, I'm Dave Fornell, digital editor with Health Imaging, and I'm here with Keith Dreyer. He is the American College of Radiology Data Science Institute Chief Science Officer. He also holds positions as the Vice Chairman of Radiology at Massachusetts General, Chief Data Science and Information Officer at the Departments of Radiology for both Massachusetts General and Brigham and Women's Hospital, and an Associate Professor of Radiology at Harvard Medical School. And I wanted to talk to you a little bit today about where we're at with AI and radiology and how these technologies are changing medical imaging.
Dave, thanks for the opportunity to chat with you. It's still early days in AI. I know we've been at this for I'd say about 5 years, since 2016. But when you think about what's necessary to build out the technology, it's very rudimentary, and most people that are driving the race cars are building them at the same time, and that never works very well. There are, as you probably know, about 200 FDA-approved algorithms out there in the United States. But it's not all created equal. So even though those 200 are from various companies, about 100 or more companies, they do very similar things oftentimes. So there's not 200 use cases. There's maybe 24 use cases. So there's multiple measurements of brain anatomy. There's multiple ways to look at mammography and find lesions, et cetera. So it's, like I say, it's really early. And I can talk more as we go on about not only the development challenges, but around the deployment challenges as well.
RSNA that you go back 5 or 6 years and they had a small AI section on the show floor, and it's absolutely exploded the last few years to where they created a third show floor just for AI because there's so much of it in its own theater for presentations. So I think it went maybe over the last 5 years from being an academic exercise. When you talk to these AI vendors, they tell you how the algorithm can identify a pizza or a cat or a dog, and the way the computer works. And I think we've kind of moved beyond that the last couple of years at RSNA, to where everybody understands the basic science, but they've realized that there's a review process with the FDA. So you do have all these algorithms approved. So what is the implementation like with these things? Because the questions really kind of changed from how does it work in the black box and to how is it going to help me?
Yeah, and even speaking about RSNA, I was asked to give the plenary session in 2016 on AI. And it was an interesting presentation because it was what the future looked like at the time, right? This was just when IBM had stepped into the field, spent $5 billion to acquire healthcare IT companies. They purchased Merge, and they were talking about general AI. And as I was talking in that early day, I said, watch year after year of RSNA, because there's going to be a lot of new companies coming, a lot of incumbents that are going to be doing AI. But I also said it's going to turn into probably a narrow AI effort, because general AI was just too far out into the future. And so, for example, if I tried to diagnose all lesions inside of a CT of the brain, that's just incredibly daunting. It's even challenging for humans to do after years and years. But to look for one specific thing on one specific modality and one specific anatomy with one type of finding, that was much more accomplishable. But at the end of that, you only achieve one thing. So you need an ensemble of those narrow AI algorithms to solve a task or a problem. And that's where we're at today. And that's why it takes so long to build out the AI. And it equally takes long to do pre-market approval with the FDA of that. And then the next step that's even more challenging is, once you get FDA approval, you want to demonstrate that these algorithms are very robust and generalizable across an entire domain like the United States. And that depends upon the conspicuity of the lesion, if you've trained it appropriately for these subtle findings, the different manufacturers of modalities, because they're not all created equal, the pulse sequences, or different ways that you can acquire data, slabs like the slice thicknesses, et cetera, as well as the demographic differences of population. So it's a multifactorial challenge when you go from the creation of an algorithm in a lab all the way to its deployment across a region like the United States. And that's why I think one major reason why deployment has been slower than was anticipated back in 2016. But also trying to deploy this inside of a well-entrenched healthcare IT infrastructure inside of hospitals is equally challenging.
in the last 5 or 6 years, I mean, has there been a movement away from radiologists and other people involved with imaging being concerned that they're going to lose their jobs because of AI, and they're actually, are they seeing a value in having this augmentation to help them?
I think that the challenge is we've done some surveys at the American College of Radiology, and we see if you try to predict the total addressable market, and the surveys that we have back from pretty good representation of our members, it appears that the market is about 2% saturated. So, there's another 98% to fill in the potentially total addressable market. Now, why is that the case? If there's pretty good enthusiasm, I think we're past the days of, this is, 6 years ago, where radiologists were fearful, of losing their job because folks like Jeff Hinton had said we should stop training radiologists right now. This was in 2016, because we're not going to need any more in 5 years, we're past the 5-year mark, and this is ridiculous. There's an incredible shortage of radiologists. So no one, I think, really fears like that anymore in the field. But I think now there's a couple of questions. What does it do for me? Right. And to your point earlier, how am I going to deploy 10 of these and make sure that they're all working in concert with each other? How do I make sure that what comes out of there gets seen by me to make sure a mistake doesn't get propagated through the care process? And then even if I do love something and I'm a radiologist in a group of 5, 10, 100, 1,000 telerad, how do I make a decision to bring this in? It's not my decision. It's some corporate entity that decides what AI comes in and doesn't come in. So it's not a fair assessment of the radiologist looking at that total addressable market and the percentage. I do think that there's much more positive take on radiologists' perception of AI than what the market would show. But that doesn't mean to say that it works perfectly today either.
And how about the reimbursement for AI? I mean, that's something else I've heard come up in sessions, is that there's not necessarily reimbursement for the AI aspect of it, but the ROI might be something else, that you're saving time. You're able to get in a few more mammograms in the afternoon and things like that.
Well, it depends, how the mainly CMS, but the other independent insurance companies and the payers look at this. There's no reimbursement for PACS either, or for RIS, or for EHR. It's just kind of practice expense. So again, thinking of AI not as a full category of something, it's just a technology. Then the question is, does this technology make you more efficient? Does it bring in some new action where you can improve care faster, so it's worth paying for it? And I think it's just very variable. I think there are not a lot of cases today where AI has proven to a payer that it's of value such that they're willing to reimburse a clinician that uses it.
Is it helping maybe pull the important reads to the top of the list, or maybe at smaller hospitals, is this an exam I should be sending on to somebody else?
So let me open that question up just a little bit. Is it saving time for the radiologist such that you make them more efficient, such that it would be worthy of purchasing? I don't see any published evidence that would demonstrate that as 100% yes. I hear anecdotal, or I hear stories or small studies that have shown it, but I haven't seen by and large that is the case. But again, it's going to be on a case-by-case basis, because it's not only just the use case that's being used or the accuracy of the algorithm, but it's also how it was implemented, that it makes you faster or slower. I always use the point that if I had an incredible autonomous vehicle software, but I had it on my iPhone and I'm driving the car, it'd be incredibly inefficient. So even the best algorithm connected in the wrong way is not going to help a lot. So I think that's really one of the challenges that's out there. And I think that there are radiologists who know what they would like to have to make them more efficient, but then to try and get that through to companies that would develop it, get through venture capital raising, get through FDA, then get integrated and deployed back out, just takes quite a bit of time today.
And lastly, what do you see as the role for ACR, RSNA, and the other radiology societies for the involvement of AI and pushing it forward? Clearly, ACR has you in a position to look at these things.
Yeah, that's a good question. And we constantly are asking our members, what is it that you would like us to do? And really try and understand voice of customer, as that's really what they are from the Data Science Institute. We also do the similar thing with vendors, because they're going to supply and provide this technology, right? So what we feel is that education is still really critical. I think the fear factor, like I mentioned earlier, is gone. But now I feel like it's our responsibility to make sure that our radiologists are really attuned to what can and what cannot happen, where these things work well, where they go off the rails, and then creating and helping to define standards for the industry so things can move faster. And then also making sure, as we've done some projects with the FDA, to make sure that this post-market analysis is done in the correct way. You know, when you think about it, the FDA can be involved with vendor activity and make sure that they direct vendor processes when they create and deploy medical devices, but they don't have that kind of control over the providers of care. And so the ACR really wants to help and step in at that national level to be able to say, okay, after this has been deployed, how do you know that you're using it appropriately? How do you know when it goes off the rails? What do you do when it does? What happens when you switch to algorithm A to algorithm B? How do you make a decision up front when you're trying to decide between 10 algorithms, which one's going to work for your population? So all of those questions to help expedite the field, but do it in the safest possible way. That's really where I think these large societies can come in and really lend a hand.
I appreciate your overview.
Sure, my pleasure.